Organic chemistry is the chemistry of carbon compounds. It's one of the subdivisions of chemistry. You may ask yourself, why are we taking time to look at organic chemistry? What's the importance of organic chemistry? And why, of all the elements, we're focusing on carbon? For the first question, we can look at another name for organic chemistry, chemistry of life. Everything that we're made of, every living organism is made of organic compounds. Understanding how these compounds go together, how they interact, and how they behave is important to actually understanding the molecular level of life. There are often very subtle differences between molecules that makes very significant changes that impact how life works. If we think of a macromolecule, a large organic molecule that you may be familiar with, DNA, when we look at the D in DNA, is for deoxyribose. This is the sugar backbone that holds DNA together. If we think about another macromolecule, RNA, the sugar in the backbone of RNA is ribose. If we compare deoxyribose to ribose, the deoxy tells us the difference. Deoxyribose is lacking a hydroxide group, an OH. Turns out this very small change in the sugar backbone makes an essential difference between the functionality of DNA versus RNA. DNA is the information that builds our cells, and we want that to be stable. RNA has several functions, but often its function is going to be based on the fact that we can make small chunks of RNA, like messenger RNA. DNA needs to be stable. RNA, we want to break up that backbone, make segments of it. Turns out that this small change, the lack of a hydroxide and the deoxyribose sugar, stabilizes DNA, where the presence of the hydroxide and the ribose sugar of RNA enables us with limited amount of energy to divide that into fragments so that we can use that to then have other functionalities like creating proteins. Now, why carbon? Now let's look at where carbon is in the periodic table. Carbon is on the center in period 2. Its electron configuration is 1s2, 2s2, 2p2. Notice it has 4 valence electrons. That's nice because it's right in the middle. Remember, we want an octet rule. We want 8. Carbon has 4. To get a perfect Nobel gas configuration, it would either have to lose 4 or gain 4. This location makes carbon not one that either loses or gains electrons, but an element that really likes to share electrons. It makes incredibly stable covalent bonds. The fact that it is in period 2 means that it is small. It's small enough that the bonds between a carbon and carbon atom are very strong, and they're close enough that we can actually get overlaps of additional orbitals so that we can get not only single bonds between carbon and carbon, but we can get double and triple bonds. The location of carbon in the periodic table also means that it only has s and p orbitals, and it does not have d orbitals. If we compare this to silicon, it means that carbon is going to be much more stable. Silicon, on the other hand, if we had a life form based on silicon, it turns out we can hydrolyze. We can take water and break silicon molecules up rather easily in comparison to carbon. Organic chemistry is the chemistry of life. It's based around carbon, and the place carbon has in the periodic table makes it available for creation of stable molecules with multiple bonds, with multiple isomers, so that we have a wealth of diversity. In this unit, we're going to learn some of the basic grammar for organic chemistry. The other reason that it's slightly different is although organic chemistry is based on all of the chemistry you've learned up to this point, it also has its own unique grammar. If we think about language, it's not that we're changing our overall tongue. We're not going from English to Spanish or French. But within a language, chemistry, it's a subtle difference, going from prose to poetry. If general chemistry is the prose of chemistry, organic chemistry is poetry. Much of the same rules, but slightly different and additional sets of values that we need to learn so that we can fully understand this. As you go through organic chemistry in this unit, you're going to get an introduction to this grammar. First, we're going to start by looking at what do we mean by covalent bonds, sigma and pi. How do we name simple organic molecules using the IUPAC system? How do we characterize different organic reactions? And how do we start to look at the reactivity of different functional groups so that we can start to understand not only organic chemistry, but at a molecular level, start to understand life, understand how we actually function.